Okay, here comes video number 2. I think I'm going to try to approach the problems in the following way from now on, which is to rewrite them so we have them to work with. We're going to look at the AP 2018 number 2, which is going to be a displacement, velocity, acceleration graph again. I'm going to do the first part of the video by solving things out, and the second part with the calculator, so you can see that saved on the computer. So first of all, they're going to give me an equation. They give me an equation for velocity, where v sub t equals this following equation right here. I know what displacement and acceleration. The integral of velocity is displacement, how far you've gone. The derivative of velocity is acceleration. And this function is defined between times 0 and 3.5. And I haven't read through the problem yet, other than to know it gave me velocity. It gave me one other piece of info, which is at time 0, the location of the object was at -5. That's going to come into play if they ask me position. Because displacement is how far you've walked. Position is where you are compared to where you started from. It'll probably come up in the problem at some point. Okay, so I'm going to look at part A. Part A says find the acceleration of the particle at time t equals 3. So that just means I'm going to find in my calculator acceleration with the derivative of velocity. So we would do d dx of f1, sorry, of f1 of x at x equals 3. I can do it in a couple of different steps. I'm just going to find the derivative of the graph at time t equals 3. I'm going to put down what the answer is when we put it into the calculator. And I'm finding v prime of 3. But I'm going to store v in f1 of x. That's why I put it there. Next it says find the position at time t equals 3. Well, the position is going to be wherever we were at the start. And at the start, we were at position -5, plus however far we walked. And remember, displacement is equal to the integral of v sub t, which is going to start at time 0 and end at time 3. Why end at time 3? That's what they told me to find it for. So we're going to put that in the calculator in a few minutes and find the answer for that one right there. So for acceleration, I took the derivative. For position, displacement, I took the integral. And the next part of the problem says evaluate the integral of from 0 to 3.5 of v sub t and the integral from 0 to 3.5 of the absolute value of v sub t and interpret. Well, it's really easy to interpret when they ask for things like this. This value is the displacement. It just means how far it's moved over that time. And absolute value is total distance traveled. And the reason you know that is, so absolute value, if we walk in positive and negative directions, just adding all those up. It's like saying, okay, for displacement, I'm starting at my house. I walk 2 miles forward. Then I walk 1 mile back. What's my displacement? Well, my total displacement is 1. I'm 1 unit from where I was home. Absolute value would say how far did you travel total? First you travel 2 miles, then you travel 1 mile, you would get 3. I'm going to compute both of these in a moment in the next video in the calculator. And you'll see I'm going to store these in the grapher just to make it so I don't have to keep retyping things in. Absolute value of v sub t dt. And the last part, the part we're least worried about, remember, we're always least worried about the last part. It gives me another function. It says there's another particle, and that particle moves along the x-axis with position, this function right here. Well, when will the two have the same velocities? It's when the two velocities are going to be equal to each other. Well, the velocity of the first one, I'm going to have graphed in f of 1. I'll do it in as x. 10 sine 0.4 x squared over x squared plus x plus 3. f2 is going to be my next function, which is going to be x squared minus x. And I'm going to graph them, and I'm going to find when f1 of x is equal to f2 of x from the graphs. as I graph them. And we'll see what happens from there. Oh, I lied to you. We don't want it, we want velocities. So this is the velocity of the first particle, v sub 1. This is the displacement of the second particle. So that means I'm not going to graph this in F2. F2 is going to be 2x minus 1. So if you had done the incorrect number, you get 1 point, so you still get half the credit. But I'm going to use the velocity equation because I have the displacement equation there. We will see all of those answered in the video coming up next. Okay, folks.